So now let's talk about a database that will appear quite a lot at the exam from an architectural point of view, which is Amazon DynamoDB. So it's a fully managed database, it's highly available, and it has replication of data across multiple AZ. DynamoDB is special because it is cloud native, it's made by AWS, it's proprietary, and it's a NoSQL database. So it's not a relational database like RDS and Aurora, although it has still transaction support. So with DynamoDB, the use case is that you can scale to massive workloads because the database is internally distributed. That means you can scale to millions of requests per second, trillions of rows, and hundreds of terabytes of storage. The idea is that, and you need to remember this, you have single-digit millisecond performance, which is going to be fast, of course, and consistent. Also, for all your security needs, everything is integrated with IAM. So for security, authorization, and administration. It's low cost, has auto-scaling capabilities that we'll see in a second, and there's no maintenance or patching. It's always available. So you don't need to provision a database. It's already there. You just need to go ahead and create a table and say how much capacity you want to put in this table. You have two kinds of table class. You have the standard class for frequently accessed data, and you have the infrequent access, the IA table class for infrequently accessed data. So the basics of DynamoDB is that DynamoDB is made of tables, but you don't need to create a database, okay? It's not like Aurora and RDS. The database is already there. That is the service named DynamoDB. So you go ahead and you create tables, and each table will have a primary key, and you decide on this at the creation time. And then you add data. So each table can have an infinite number of items, and there are rows, and each item will have attribute. And they're pretty much columns. But you can add the attributes over time, and they can be null. So this is a big difference in an RDA. Or a database, you can add columns over time, but it's a complicated process and it can be difficult to evolve your schemas. But then in DynamoDB, you can add attributes just like that over time without any pre-requirements. So the item size, the maximum item size in DynamoDB is 400 kilobytes. So DynamoDB is not there to store very large objects. You have different data types supported. You have the scalar types such as string, number, binary, boolean, and null. You have list and maps and sets. So DynamoDB is at the exam going to be a great choice if you need to see from the exam that the schema, so that means how your data looks, how it's shaped, if the schema needs to rapidly evolve. In that case, DynamoDB is a a much better choice than Aurora or RDS. So look for this at the exam. So here is an example of a table in DynamoDB. We have a partition key, optionally a sort key, which composes your primary key. And then we have attributes. And then it looks just like a database, okay? But it's possible, for example, for your attributes to be null or to add attributes over time, which makes the strength of DynamoDB. Another thing you need to choose, if you need to choose DynamoDB, is the which makes the strength of DynamoDB. Another thing you need to choose, if you need to choose DynamoDB, is the capacity mode for reads and writes. So you can control how to manage your table's capacity, and there are two modes you need to know about. There is the provision mode, which is the default, in which you are going to provision the capacity in advance. So you're going to say how many reads and writes you expect per second, and that's going to be your capacity of your table. So you need to plan the capacity beforehand, and then you're going to pay for every provisioned RCU or WCU, which stands for read capacity units or write capacity units. Although if you want to plan capacity, you can still automatically adjust it thanks to auto-scaling, which will increase or decrease your RCU and WCU over time based on the load of your table. So this is the provision mode, and it works great if your load is predictable, it evolves smoothly, and you want to do some cost saving. But there is also the on-demand mode. And here, the read and write capacity will scale automatically with your workload. There's no capacity planning needed. There is actually no concept of RCU and WCU. So instead, in the on-demand mode, you're going to pay exactly for what you use. So for every single write and every single read, you're going to pay for it. So it's a lot more expensive as a solution, but it's going to be amazing for unpredictable workloads or workloads that have a steep, sudden spikes. So again, these are some keywords you need to look at for the exam. If you have an application that will scale from 1,000 transactions to 1 million transactions in less than a minute, provision mode is not going to be good for you because it doesn't scale fast enough. So in that case, you need to use on-demand mode. Or if you have a workload that has no transactions at all, maybe 4 or 5 times a day maximum, then on-demand mode is great because you're only going to pay for these 4 or 5 transactions. So look out for the differences and these keywords, and you will be able to select between provision mode and on-demand mode. So that's it for the DynamoDB basics. I hope you liked it, and I will see you in the next lecture. So let's have a first look at DynamoDB. And so DynamoDB allows us to create table. As you can see, I just click on create table, and there's no such thing as creating a database. So right away, we have to create a table, which makes it a serverless database. So the table name is going to be demo table. And here we have to choose what's called a partition key and optionally a sort key. And the combination of these two columns is going to make your primary key. So to make it very simple, I will just have user ID as my partition key, and I will not specify a sort key. Now for the settings, this is where it gets important from an exam perspective. So we're going to customize the settings to have a look at all the options we have. So for read and write capacity settings, we have two options. We can either go on demand or provisioned. So on demand is very simple. We're going to pay for the actual reads and writes that your application will perform. And again, I said this is great when your application has unpredictable workloads because, well, on demand is 2 to 3 times more expensive than provision capacity. So use at your own risk, obviously, but this can be a great use case and a great fit for many kind of scenarios. And this is what the exam will test you on. Now, provisioned is when you need to manage and optimize your cost by allocating read and write capacity in advance. So we have two options. We have read capacity and write capacity. And so for these, we have either autoscaling or enough. So autoscaling applies to read and write capacity. So if we specify it off, then we have to provision capacity units. So we can say, for example, I want to provision 10 capacity units. And for write capacity, you can say I want to provision 5 write capacity units. Okay, so that's one way of doing it. Or if we don't know ahead of time what we will need in terms of capacity, we can say, hey, min is max, min is 1, max is 100, and I want a target utilization of 70%. And automatically, autoscaling activities will take place to manage your read capacity to match about the 70% of the target utilization, which is true for read capacity and for write capacity. So I'm going to turn it off right now, and I'll just set it to 1 and 1, but it shows you these two very, very important options you need to know. Next, we have indexes, and indexes, I will discuss them in the next lecture, so let's skip them for now. And by the way, if you want to know how to find out which read and write capacity is right for you, there's a capacity calculator. Now, this is a bit more complex. This is more relevant for the developer exam, so I'm not going to go over it. Okay, so we're going to scroll down. So as you can see, because we have one RCU and one WCU, we have an estimated cost of 71 cents per month for this table. So this gives you information around the pricing of DynamoDB. Okay, now we will enable encryption at rest, and then I will click on Create Table. So now that my table is created, I can click on it, and then on the right-hand side, I can have a look at View Items. And this is just to show you how we can insert items into our DynamoDB table. So as we can see, we can create an item, and we need to specify a user ID, for example, Stefan_123. And then we can start adding attributes into this table. So we can say name is Stefan Merrick, and then we can have an example around another one, for example, favorite movie. And you can say memento, and then maybe a number, favorite number, 42. Okay, and we're going to create this item. And as you can see now, the item has been inserted into my table. So it's quite easy to reason about. And we can create another item, obviously. We can say Alice456. And again, we can set the name of Alice to be Alice Doe. And then we can just say favorite movie, and then Pocahontas. Okay, great. So I will create this item. And maybe we can add also a number called age. And here I will say 23. Okay, let's create this item. So as you can see in this example, I specified different attributes for Alice than Stefan. And the idea is that in DynamoDB, you don't need to have all the attributes filled out for all the items. Actually, every item can have different attributes. So this shows you the whole power of DynamoDB table. A NoSQL type of technology versus a SQL type of technology. So it's very simple. Now we have Alice and Stefan in our table. And I'm not going to go too deep into DynamoDB. As you can see, there are a lot of options. So if we go back into our table, there are a lot of options in here available to us. But in the next lecture, what I will do is that I will describe what are some of these options that can be important for the exam are. And what you need to see just in this lecture was how to set the read and write capacity units or the on-demand mode, as well as inserting some data into a DynamoDB table. So I hope you liked it, and I will see you in the next lecture. So let's talk about the advanced features that can come up at the exam for DynamoDB. And the first one is DynamoDB Accelerator, or DAX. So this is a fully managed, highly available, and seamless in-memory cache for DynamoDB. The idea is that if you have a lot of reads on your DynamoDB table, then you can create a DAX cluster to solve read congestion by caching the data. And with DynamoDB DAX, you get microseconds latency for cache data. So this is something you have to look out for in terms of keywords at the exam. It doesn't require for you to change any of your application logic because the DAX cluster is compatible with the existing DynamoDB APIs. So you have your DynamoDB tables and your application, and you would just create a DAX cluster made of few cache nodes, connect to this DAX cluster, and then behind the scenes, the DAX cluster is connected to your Amazon DynamoDB table. The cache has a default TTL of 5 minutes, but you can change this. So you may ask me, why should I use DAX and not Elasticache? Well, DAX is in front of DynamoDB, and it's going to be very helpful for individual objects cache or queries and scan queries cache. But if you want to store, say, aggregation results, then Amazon Elasticache is a great way to do it. So if you want to store a very big computation that you've done on top of Amazon DynamoDB. So they're not drop-in replacements for one another. They're actually complementary. But most of the time, for a caching solution on top of Amazon DynamoDB, it's just going to be using DynamoDB Accelerator DAX. You can also do stream processing on top of DynamoDB. The idea is that you want to have a stream of all the modifications that happen on your table. Would it be create, update, and delete? And the use cases for that will be, for example, to react to changes on your DynamoDB table in real time. For example, to send a welcome email whenever you have a new user in your users table. Or so you may want to do real-time usage analytics, or maybe you want to insert data into a derivative table, or you want to implement cross-region replication, or you want to invoke Lambda on any changes made on your DynamoDB table. So two kinds of stream processing on DynamoDB. You have DynamoDB streams with 24 hours retention, a limited number of consumers, and is going to be greatly used with Lambda triggers, or if you wanted to read it yourself, there is something called the DynamoDB Stream Kinesis Adapter. Or you can also choose to send all your changes directly into a Kinesis data streams. And here you can have up to 1 year of retention. You can have a much higher number of consumers, and you have a much higher number of ways to process the data, whether we blend the functions, Kinesis Data Analytics, Kinesis Data Firehose, Glue streaming ETLs, and so on. So let's have a look at an architectural diagram to understand DynamoDB streams better. So your application does create, updates, and deletes operations on top of your DynamoDB table, which is going to be either a DynamoDB streams or a Kinesis data streams. If you choose to use Kinesis data streams, then you can use Kinesis Data Firehose. And from this, you can send your data into Amazon Redshift for analytics purposes, or Amazon S3 if you want to archive some of the data, or Amazon OpenSearch to do some indexing and some searches on top of it. Or if you are using DynamoDB streams, you can have a processing layer and you can use either the DynamoDB KCL adapter to run your applications on top of EC2 instances, or Lambda functions. And from there, do some notifications on top of SNS or do some filtering and transformations into another DynamoDB table, or use the processing layer to do whatever you want. So such as, again, send the data to Amazon OpenSearch. So I didn't represent all the possibilities of our architectures. Of course, you can have EC2 instances reading from Kinesis data streams. You can have Kinesis data analytics and so on top of Kinesis data streams. Many, many transformations. But again, you know enough now to figure out what is going to be the right architecture at the right time. DynamoDB also has a concept of global table. So a global table is a table, of course, that is going to be replicated across multiple regions. So you can have a table in US East 1 and a table in IP Southeast 2. And there is a two-way replication between the tables. That means that you can write to a table either in US East 1 and AP Southeast 2. So here, the idea with global tables is to make DynamoDB accessible with low latency in multiple regions. And it is an active replication. That means that your applications can read and write to the table in any specific region. And to enable global tables, you must first enable DynamoDB streams because this is the underlying infrastructure to replicate a table across regions. DynamoDB also has a feature named time to live, or TTL. The idea is that you want to automatically delete items after an expiry timestamp. So you have your table, session data, and then you will have one last attribute called expiration time, which is your TTL, and it has a timestamp in it. And the idea is that you're going to define a TTL, and as soon as the current time in the epoch timestamp is going to be over your expiration time colon, then automatically it's going to expire items and then eventually delete them through a deletion process. So the idea is that the items in your data table are going to be deleted after a while. So the use cases for this would be to only store data by keeping only the most current items, or to adhere to regulatory obligations by, for example, deleting data after 2 years. Or another use case that is very common at the exam is the web session handling. So a user would log into your website and then would have a session, and you would keep the session in a central place such as DynamoDB for 2 hours. And you would set the session data there, and any kind of applications can access it. And at some point after 2 hours, if it hasn't been renewed, then it will expire and move away from this table. You can also use DynamoDB for disaster recovery. So what are your backups options? Well, you can have continuous backups with point-in-time recovery, PITR. So it's optionally enabled, but you can have it for the last 35 days. And then if you enable it, you can do a point-in-time recovery to any time within the backup window. And if you do happen to do a recovery, then it will create a new table. If you wanted to have longer term backups, then you can use on-demand backups, and they will be retained until you delete them explicitly. And doing these kind of backups do not affect the performance or the latency of your DynamoDB table. And if you wanted to have a better management of your backups, you can use the AWS backup service, and this will enable you to have lifecycle policies for your backups and so on, and also copy your backups across regions for disaster recovery purposes. And again, if you were to do a recovery of one of these backups, it will create a new table. Now let's talk about the integrations between DynamoDB and Amazon S3. So you can export a table into S3 just like this, and to do so you must enable point-in-time recovery. And you would export a DynamoDB table into S3, for example, if you wanted to do some queries, for example, using the Amazon Athena engine. So you can export at any point in time during the last 35 days because you've enabled continuous backups. And when you do an export, this does not affect the read capacity of your table or your performance. So with this, you can perform, for example, data analysis on top of DynamoDB through exporting through Amazon S3 first. You can also use this to retain snapshots for auditing or to do any kind of big transformation, maybe any ETL of the data before importing it back into a new DynamoDB table, for example. The format of the export can be in DynamoDB JSON or the ION format. And similarly, you can import to Amazon S3. So you can export from S3 into the CSV, JSON, or ION format back into a new DynamoDB table. And this does not consume any write capacity, and it will create a new table. If there are any import errors, they will be logged in CloudWatch logs. So that's it for DynamoDB. I hope you liked it, and I will see you in the next lecture. So far in our serverless journey, we've seen how to create Lambda functions, and we've seen how to use DynamoDB. And so Lambda functions can use DynamoDB as a database for our API, and we can do create, read, update, deletes on our tables. But we'd like our clients to be able to invoke this Lambda function in some way. So there are multiple ways of doing. Doing it, we can have the client directly invoke the Lambda function. That means that the client would need IAM permissions. Or we've seen we can use an application load balancer to have it in between the client and the Lambda function, and that would expose our Lambda function as an HTTP endpoint. There's one last thing we can use. It's called the API Gateway, and this is a serverless offering from AWS, which allows us to create REST APIs that are going to be public and accessible for our clients. So the client will talk to the API Gateway, and the beautiful thing is that the API Gateway will then proxy the request to our Lambda functions. So we would use an API Gateway because it provides us more than just an HTTP endpoint. It will provide us a lot of features, as we'll see in this section, such as authentication, such as usage plans, development stages, and all that kind of things. So the API Gateway has a lot of features, and this is just an overview, but we can integrate the API Gateway with Lambda, and that gives us a full serverless application, so no infrastructure to manage. We have support for the WebSocket protocol, so we can do real-time streaming through the API Gateway in 2 different ways. The API Gateway handles API versioning, so we can go from version 1 to version 2 and version 3 and not break our clients. We can handle multiple environments. That includes the dev, the test, and the prod environment. There is a whole thing about API Gateway and security, so there's a tons of ways to enable security on your API Gateway for both authentication and authorization. We have the ability to create API keys, do request throttling in case some clients are doing too many requests on our API Gateway. And we can also use some common standards such as Swagger or OpenAPI 3.0 to import quickly defined APIs, and also we can export them as Swagger on OpenAPI. We can transform and validate request and response in the API Gateway level to ensure that the invocations are correct, and we can generate SDK and API specifications and cache API responses. So lots of features that come with the API Gateway that are not necessarily included when you use something as simple as an application load balancer. So what does the API Gateway integrate with? Well, there is a Lambda function, and we've seen this from the previous diagram, so it can invoke a Lambda function. And with this integration, it is the most common way and a very easy way to expose a REST API backed by a Lambda function to do a full serverless application. But also HTTP, so we can expose any HTTP endpoints in the backend. So it could be, for example, an HTTP API you have on premises, or it could be an application load balancer you have on your cloud environment. And why would you do this? Well, you would use an API Gateway to leverage the rate limiting features, the caching, the user authentication, the API keys, etc. So it's definitely useful to have a layer of API Gateway on top of your HTTP endpoint. And finally, we can use an AWS service. So we can expose any AWS API through the API Gateway. So which ones, for example? Well, we can start a step function workflow. We can post a message to SQS directly from an API Gateway API. Why would you do this? Well, because maybe you want to add authentication, deploy some APIs publicly, or do some rate control on some AWS services. So here is an example of the API Gateway used with an AWS service, so for example, Kinesis data streams. So we want to have people send data into a Kinesis data streams, but in a secure way without giving them access to AWS credentials. So what we do is that in between our clients and our Kinesis data streams, we're going to have the API Gateway. And the clients will send HTTP requests into the API Gateway, and it's been configured to then send the messages into a Kinesis data streams. And as you see in this setting, we don't manage any servers. Then Kinesis data stream, from there we can, for example, send the records into a Kinesis data firehose and eventually put them into an Amazon S3 bucket in the JSON format. So you start to see the power of API Gateway. You can actually expose any AWS service to the outside through an API Gateway. There are 3 ways to deploy your API Gateway. This is called endpoint types. So the first type, which is the default one, is called edge optimized. This is for your global clients. So that means that your API Gateway is going to be accessible from anywhere in the world. And to be efficient, the requests are going to be routed through all the CloudFront edge locations, which will improve the latency. Your API Gateway is still only in one region where you created it, but it's accessible efficiently from every CloudFormation edge location. Then there's a regional deployment. So this is when we don't want to use CloudFront edge locations. So it's when we expect all of our users to be within the same region where we created our API Gateway. And if you wanted to, you could create your own CloudFront distribution, and this will give you the same result as an edge optimized distribution, but this time you have more control over the caching strategies and the CloudFront settings themselves. And then finally, the last kind of API Gateway you can do is a private API Gateway. So this time it's not public. So a private API Gateway can only be accessed from within your VPC, and it will use interface VPC endpoints or your ENIs. And to define access to your API gateway, you can use a resource policy. Now, a few comments about the security on top of the API gateway. So you can identify users on the API gateway in multiple ways. The first way is through IAM roles. So this is very helpful. If you have external users, for example, for mobile applications or web applications, then you would use something called Amazon Cognito. Or if you wanted to implement your own logic, you could do so with a custom authorizer. This is a Lambda function. Also, you can have HTTPS security through your own custom domain name, this one, but if you're using a region record in Route 53, to point to your domain and an API gateway. So that's it for this lecture. I hope you liked it, and
Welcome to this data engineering crash course created by Justin Chow. This course covers the essentials of data engineering. You'll learn about databases, Docker, and analytical engineering. You'll explore advanced topics like data pipeline building with Airflow, and you'll engage in batch processing with Spark and streaming data with Kafka. The course culminates in a comprehensive project, putting your skills to the test and creating a full end-to-end pipeline.
Hey everyone, welcome to the course. My name is Justin Chow. I'm a developer advocate at Airbyte. I'm going to be going through kind of essentially what you need to know in order to become a data engineer, what goes into data engineering, and then this is going to go into a fully fledged demo where you can follow me in creating a data pipeline from scratch and then evolving that into a fully fledged data pipeline using open source tools such as Airbyte. So hopefully you enjoyed this and this gathers some interest. If anything along with data engineering or software engineering in general is of interest to you, then this should be good to know. But without further ado, let's get into the course. So we're looking over the introduction to data engineering, but you may be thinking, why data engineering in the first place? Well, there's a couple of reasons why you may want to consider getting into data engineering. First, there's a high failure rate of big data projects, and the percentage there based off of the data that we've collected is 85 to 87% of those projects failing. And obviously, as I've said, that's pretty high. Those failures are due to unreliable data infrastructures and quality, which is just a lightweight form of, and then a couple other things like successfully. Now we can say exit, and now we have a to-dos database. We're going to skip this part because it's not really necessary, but if you want to follow it, it's simply, we have a last name, which is the same thing. We have an email that is also characters, but we want it to at least be 100. And then we have a date of birth, which is just in the type of date. So we're going to hit enter. It's going to show us that we have a table. So now if I in conjunction with select is also going to be distinct. We use distinct in conjunction with select and change the email over to the new. Go over what those are right now. Let's go ahead and do that. I have here a look at all these services as a single container. In each single container contains an image that the runtime is going to use those and dump files into the destination. So that's exactly how we're going to be using this batch script here for our ELT. And so we're going to say source underscore DB is going to be the name of our DB name. That's actually the exact same thing, except we're going to be using the destination here. Destination config. Now we need to execute the load command. So what we're going to do is we're going to say subprocess.run load command. env is going to equal subprocess underscore env, and then we're going to do the check equals true again, and we're going to print, just for our own purposes, ending ELT script. Subprocess.run dump as rating underscore category. So that ends this case statement here, and this is without any data persisting. So that's the only reason why I'm doing that. So now we Docker compose up again. This should work unless I've made even more typos. Okay, so we're doing that again. There we go. Okay, so now you can see that we've successfully, that we're going to use is, let's say we wanted to select a specific title, but using a Jinja, so we didn't have to actually put it within our actual SQL query. That's what it allows us to do. It could allow you to select, do we want to use the prod target instead of the dev target inside of our DBT project? Then we could do that as well. And we can change the way that queries are done, again, adding a control structure. So let's go ahead and inside of our example folder, we're going to create a file called specific underscore movie.sql. And inside of that is where we're going to start with our Jinja here. So again, starts with a curly brackets and then 2% signs. And inside of that, we're going to say sets. So when you see sets, that is essentially what is starting our control structure here. And we're going to set film underscore title, simple example of what a Jinja is and kind of how it works, but go ahead and play with it. I implore you to kind of, integrate Jinjas with macros to really, use the full power of macros and Jinjas together. And I think it could really 10x your SQL queries and your custom models from within dbt, and really just excel that process of the whole data engineering slash data analytics process altogether. Okay, so as I've mentioned before, we're going to be adding a cron job to this. Not ideal, I guess you could say, in the sense of to orchestrate all of our tasks together. Project, open source projects, Airflow, and then latest. This is going to be the same for pretty much every single, I think it's going to be the same for every single one, but I could be wrong. Anyway, so image, this is going to depend on Postgres because we need that database to be initialized essentially before we initialize Airflow, because without it, we're going to have some errors here. Networks, again, we're going to say ELT_network. For the environment, we're going to say, this is going to be a long one. So Airflow _, so two underscores, database __ SQL _alchemy _con for connection is going to equal, and this is going to be pointing to our Postgres database here that we just created. So Postgres plus psy copy2 / Airflow for username and password here at Postgres / Airflow. Okay, so that's
Hadoop is a big data processing framework that has revolutionized the way we store and analyze large volumes of data. In this video, we're going to explain what Hadoop is, how it works, and has since become one of the most useful because it doesn't fit neatly into tables or rows. Up into small pieces called blocks, which are distributed across the cluster. This ensures that the data is always available, even if one of the computers in the cluster goes down. But storing data is only half the battle. The other half is processing that data. This is where the MapReduce framework comes in. MapReduce is a programming model that allows you to use a set of key-value pairs, while reduce functions take in those key-value pairs and produce a final result. The beauty of MapReduce is that it allows you to process data in parallel across the cluster, which means that you can analyze massive amounts of data in a relatively short amount of time. So, now that we know what Hadoop is and how it works, let's talk about why it's such an important.
One of the most common use cases for Apache Airflow is to use it for ETL and ELT pipelines relating to analytics. Here you can see a simple example of such a pipeline. We have two extraction DAGs that extract data from an API. We have one ingestion DAG that ingests data from a data warehouse, and we have two transformation DAGs that transform the data to be in the exact right format. All of these
In this video, I will explain what Ansible is and show different real-life scenarios where it can be used to make IT processes efficient. We're going to look at Ansible components like playbooks and why it's a good idea to use Ansible with Docker. And at the end, we will compare Ansible with its alternative tools like Puppet and Chef. In this video, you will learn what tools you need to learn to become a DevOps engineer and what are the tasks and responsibilities of a DevOps engineer. First, you need to understand that there are two main parts when creating an application. The development part, of course, need development and testing or staging times. Creating and maintaining, so we don't want to do it manually, automate this process on that using a and configuration management tool like Ansible or Chef, etc. So you as a DevOps engineer should know one of these tools to make your own work.
Hi, my name is Bart Becker and welcome to another video. At Grafana Labs we use Tanka to manage our Kubernetes infrastructure deployments. Kubernetes uses the YAML format to express these deployments with specifications for things like containers, volumes and networking. However, YAML is designed for representing fairly simple data structures, not for complex Kubernetes. deployments. The result is a huge amount of repetition and boilerplate code in tons of YAML files. This makes it very hard to see the forest for the trees. Several open source projects aim to make working with YAML a bit less painful. They typically use templating to generate all that YAML code for you. Helm is one of the most popular projects, and it's a great tool for when you're just starting out with Kubernetes. But at Grafana Labs, we quickly ran into its limitations. Heavily inspired by a project called KSonnet, we've created Tanka. It uses the JSonnet data template language to generate all the required YAML. Check out the blog post by Tom Braak to read all about the limitations of Helm and how Tanka solves them. You can find the link in the video description below. In today's video, we'll focus on getting Tanka up and running for our first deployment. First, we'll install Tanka. Next, we use Tanka for our first deployment of Prometheus and Grafana. And finally, we're gonna make a small change to our deployment configuration and do a second deployment. Alright, let's install Tanka. We'll download the binary and make it available as an executable. Make sure to download the binary that matches your platform. In this case, I'm on a Mac, so I need the Darwin binary. Let's make the TK file executable. Tanka depends on JSonnet Bundler for JSonnet package management. The installation is very similar. Great, we have everything we need to create our first Tanka project. Let's create a directory for our new Tanka project called Tanka Tutorial. By running tk init, we get all the files needed to generate a valid Kubernetes deployment. Next, we'll add the deployment configuration for Prometheus and Grafana as a library. This allows us to reuse this configuration across multiple Kubernetes environments, for example, development and production. First, we'll create a config file which contains our library configuration parameters. This file is not required, but for clarity, it's good practice to keep a separate file that defines all the configuration values that we likely want to customize per environment. In this case, we'll make the ports, names and images to be used for Grafana and Prometheus configurable. Next, we'll create a libsonnet file that will generate the deployment and services YAML for both Prometheus and Grafana. A lot of things are happening in this file. First, we import two files. The first file, Castle, wraps the JSonnet Kubernetes library with some shortcuts for additional productivity. The second file contains our configuration values. And this segment creates a few aliases to the Kubernetes objects we need, so we don't need to type the full namespace every time. Here we define the Prometheus deployments and services using our JSonnet template language. In these definitions, we can reference the configuration values as variables. JSonnet will make sure that this all compiles to valid YAML. Great, our library is done. Let's use this library in a new production deployment. We'll create the configuration for a production environment using the Tanka command. This will generate a production directory with two files. The spec file contains the Kubernetes API connection details from the active context. And in the main file, we'll specify our deployment configuration. We'll import our Prometheus and Grafana library and override the default configuration. Let's specify a specific image version to use in our production environment. Okay, that's enough JSON for now. We're ready for our first deployment. With tk show, we can see the YAML that will be generated from our JSonnet code. Any syntax errors will be shown and no invalid YAML will be outputted in that case. All resources will be created under a namespace from Grafana prod. We'll create this namespace with kubectl. Using tk apply, we deploy the current configuration to our Kubernetes cluster. Apply, we deploy resources will be created under a namespace from Grafana prod. We'll create this namespace with kubectl. Using tk apply, we deploy the current configuration to our Kubernetes cluster. Kubernetes cluster. We'll create this namespace with kubecontrol. Using tk apply, we deploy the current configuration to our Kubernetes cluster. And we're done! Grafana and Prometheus are deployed and running. Now let's make a small improvement to our deployment and apply these changes. We'll upgrade production to the latest and greatest Grafana by changing the image version in our main file. With tk-diff, we can see the difference between the deployed configuration and our local changes. Let's deploy this new version. Great, we're now running the newer version of Grafana on our Kubernetes cluster. Great. We'll upgrade production to the latest and greatest Grafana by changing the image version in our main file. With tk-diff, we can see the difference between For now, we're ready for the active content. main file. With take-a-diff, we can see the difference between the deployed configuration and our local changes. Let's deploy.
Hey, this is Andrew Brown over here on Free Codecamp, bringing you another free cloud certification, and this time it's the HashiCorp Terraform Associate version 3, and the way we're going to achieve certification. Let's take a look. And to even handle cross-cloud dependencies, and that is a big deal. Looking at the fact that we want to lean towards doing an approach with Packer, right? We want to Baker values which should cause this set of provisioners to rerun. So values are meant to be interpolated references to variables or attributes of other. resources. And triggers are interesting because I think we also see them in Terraform Cloud. Not sure if this is the same kind of functionality, but yeah, that's null resources, okay? All right, let's take a look at Terraform data. So this is very, very similar to null resource, but the key difference here is that it does not require or the configuration of provider, because when you install null resource, it actually installs a provider called null. And so now it's just with this Terraform data, you can do something very similar like this with null resource and literally replace it with Terraform data. And for more or less, it will do the same thing. Now, it's not one-to-one because some of those parameters are a little bit different. So instead of triggers, we have triggers replace. But more or less, you can almost replace it and get the exact same result. I would recommend it over using null. I was trying to figure out if there was a case where you'd want to use null resource, but I really could not determine that. It did not seem like there was anything additional. So yeah, there you go. It's as simple as that. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at Terraform providers. So providers are Terraform plugins that allow you to interact with cloud service providers like AWS, Azure, GCP, software as a service providers, so GitHub, Angolia, Stripe, or other APIs such as Kubernetes or Postgres servers. There's a lot there. There's like over 1,000 providers. So providers are required for your Terraform configuration file to work. So you have to have at least one provider. Providers can come in 3 different tiers. We have the official one, so published by the company that owns the provider technology or service. Verified, so actively maintained, up to date, and compatible with both Terraform provider. Community, so published by a community member, but no guarantee of maintenance, up to date, or compatibility. Providers are distributed separately from Terraform, and the plugin must be downloaded before use. So if we do Terraform init, this will download the necessary provider plugins listed in the Terraform configuration file. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at the Terraform registry. So this is a website portal to browse, download, or publish available providers and modules. And just remember, providers and modules are plugins within Terraform, both of them, okay? So to get to this website, we go to registry.terraform.io, and everything published to the